In this section, we are going to talk about using the central limit theorem. So there's a couple rules that I want to go over first, and then we'll start doing some example problems. So if you're asked to find the probability of the mean, you need to use the CLT for the mean. If you're asked to find the probability of a sum or a total, then you need to use the CLT for sums. And if you're asked to find the probability of an individual value, then you should not be using the CLT. You need to use the distribution of its random variable. All right, at the top here, I've just rewritten some information of our CLT for mean and the CLT for sums. This is just for easy reference as we solve the problems. So this is nothing new. This is just notes to help us solve these problems. So let's get started. A study involving stress is conducted among the students on a college campus. The stress scores follow a uniform distribution, with the lowest stress score equal to 1 and the highest to 5. Using a sample of 75 students, find, and then we have 4 questions here. So the first thing I want to do is I want to write out all the information that I know. So we are going to let x equal 1 stress score. We know that we have a uniform distribution. So random variable follows a uniform distribution of 1, 5. Recall that uniform distribution, this 1 is our A value, B is our 5, A is the lower value, and B is the upper value. So then we will rewrite A equals 1 and B equals 5. So just keep this in mind when we're doing these other problems. A is 1, so the lowest possible score is 1 and the highest is 5. That's going to be important later. And then our n value, our sample size, is 75. So this is all the information that we've been given. Let's go ahead and tackle this first problem. It says the probability that the mean stress score for the 75 students is less than 2. So here we've got the mean, so we are going to be using CLT for mean. So we are looking to find the probability that the mean score is less than 2. That's what we are trying to find. So when we are using the mean, we can look back up here, and this is our reference point, right? This is our notation that gives us all the information that we need. So we are going to rewrite what we need to find. All right, so these are the values we need to find. We need to find the mean. The mean, if you look back in the continuous random variable chapter, you can find that the mean is a plus b divided by 2. Okay, so our mean is 3 in this case. And then let's find what our sigma is. Again, that's back in the previous chapter, and that is how we find sigma. So let's put that in the calculator. So we do the square root of 5 minus 1 quantity squared divided by 12, close parentheses, 1.15. So now that I have my values, we can go ahead and calculate this. So to find the probability that it's less than the mean stress score is less than 2, we will use normal CDF. Our lower value, the lowest we can have is 1. The highest would be 2. Our mean is 3. And then our next value needs to be 1.15 divided by the square root of 75. So let's put that in our calculator. We get 0. So the probability of getting less than a 2 is 0. Now let's take a look at B. B says the 90th percentile for the mean stress score for the 75 students. So we are doing mean again. This one is our K equals the 90th percentile. So whenever we are looking for a percent, we're going to use inverse norm of 0.9, and then we get our mean value, and then we get divided by square root of 75. So let's put this in, and let's find out what value we get for this. 0.9, 3, 1.15 divided by the square root 75, 3.17. And so what does this mean? Well, this means, let's just review, this means that 90% of all the means of 75 stress scores are at most 3.17. All right, now let's solve the last two, C and D. So C and D, you can see we've highlighted here total. So these are going to be using the CLT for sums. So the probability that the total of the 75 stress scores is less than 200. So we are trying to find the probability the sum of the stress scores is less than 200. Now for this one, I want you all to remember that we're not using these values anymore. This was the CLT for the mean. We're going to go back all the way up here. We are going to be using the CLT for sums to answer these next two problems. Okay, so let's write our notation out. N, so we do n times mu, and then the square root of n times sigma. So let's rewrite this. That should be a big N in front of there. N is 75 times the mean, which is 3 square root of 75 times 1.15. Now, excuse me, we are able to use, so these values do carry down here for us. So all we are going to do is use our calculators, normal, CDF. And if you recall, up in A and B, our lowest value that we could get was 1. Now, as we are working with the sums, and there are 75, sum means we're adding them all together, then the lower value isn't 1 anymore, it's 75, because 75 ones is 75. So that's our lowest value. Highest value, we want less than 200. And do the rest of these values. That is 1.15. And let's just put that into our calculator. 75, 200, 73 times 5, square root of 75, close parentheses, times 1.15. And we get 0. So there's a 0% probability that the total of the scores is less than 200. Last one is the 90th percentile for the total stress score for the 75 students. So here we are looking for K equals the 90th percentile. We are trying to find our K value. We are going to use the inverse norm of 0.90 and then 75, wow, I wrote that backwards. Okay, 75 times 3, so 75 times 3, and then square root of 75 times 1.15. If you wanted to go ahead and get those numbers and just put those in here, you could do that. So inverse norm, 0.9, 75 times 3, square root of 75, close that parentheses, times 1.15. We get 237.8. So what this means is 90% of all the sums of 75 scores are no more than 237.8.